So now if I play, in my level I have the enemy base and the spawner test, um, and um, it's in the air to see actually the results. And if I play, I will press 2, the enemy health goes to 90, spawns the giant enemy in phase 1, spawns a random number of mini enemies in phase 2, in phase 3 I don't have anything, and on death, when he dies, it spawns the loot with the rarity. So if I play again and spam, now the shield is rare, the wooden sword is also rare, this is common, this is uncommon, and every time it's something different, completely random. And if I press 3 now, I set the timer, the delay, and after 5 seconds I can spawn many enemies. And yeah, this is basically I can, um, it needs to have some sort of better calculation about position and location, because some enemies may overlap with others. But for now, just for testing, it's very nice, I think. And it spawns every time. So now this is epic, this is poor, this is uncommon, and this is common. Hello everyone. In the previous video, I made a very simplified system of loot drop that I want to make. That being said, I would like to use the asset manager, and instead of using the base class of type actor, I would like to use a base class of type primary data asset. So a quick review of the project. I have in the asset manager two elements to scan. One is primary asset type of weapons, and the base class is weapon base. And another one is item test and is item base. For this video, we won't really use these primary asset IDs. We don't need, but a quick review um, is I made some blueprint classes. They all inherit from the item base. Inside the item base, I have two functions that show static mesh or skeletal mesh, and they take the data from a generic primary data asset that holds a skeletal mesh and a static mesh soft object reference, and a boolean to see if it's a skeletal or a static mesh. That's all for the item base. The other thing that I did was to separate the blueprint in categories, weapons test, items, cube test, but that doesn't matter for this video. The other thing is made a component that holds a primary data asset. The primary data asset has an array of struct information, and the struct has a class ID, probability to get spawned, a min-max quantity, a phase tag. I didn't use, but the idea is that you have another runtime array, and you add the runtime array to not lose any data in between. Then I async load the primary asset class list, and then I have a ready array to cast to actor class and then spawn. Uh, for this, for the previous project, uh, that's all. It doesn't matter if you saw the previous one because in this one I will use um, primary data asset as primary asset ID. Now, before I make the primary data asset, I will make it in C++. I want to make in the data structs of the spawn system three structs. So I don't waste any time later. And an enum. So this will be spawn type. And for this enum, I will put some it's basically for to direct what is getting spawned. Like you could have an enemy or an item or some effect to lose health. The first one is none. The second one is item. The third one is enemy. And lastly, effects. Next, I will create, what is it? Some structs. One is set as element information, and the other one will be rarity information. For the element information, I will have two variables. One is element tag, and the other one is a float probability. So probability and play tag float. Okay. And lastly, I won't use this struct, but I will make a new one, and this will act as a runtime struct. So spawn info runtime, and for this one I will have several variables. One is the actor class, so actor class, and this will be an actor and class reference. The other one will be a total quantity, and this will be an integer. A face tag, and this will be a gameplay tag. Another one will be the spawn type, and this will be e spawn type. The scale of the item or the enemy that we want to spawn, and this will be a vector. The rotation of type rotator. Another one will be on drop, and this will be a sound base soft class reference. I believe that's all for now. So now I can go inside my spawn component and give this struct as an array, as uh, spawn info runtime, and this will be of type as spawn info runtime, and there will be an array. And this will be private because only the component needs to know about the runtime. The enemy doesn't care, or the spawn class that you have. Now, because I don't want to waste any time, I will make a C++ class that is of type primary data asset. Okay, I made the primary data asset. I named it my primary data asset, and the only thing I need is the .h file, the header file, and not the CPP. And this will store only variables. The first one will be a tsoft class pointer, pointer of actor. Let's name it actor class. And this very important, and this is why I'm doing the C++ class, because now I can say u property of type and say edit anywhere, blueprint read only, asset h3 searchable, category, let's say spawn info, and the most important is the meta tag. Meta equals, I can give a bundle now, asset bundles equals, and say maybe loot. Okay, this is the most important. That being said, I will say u property edit anywhere blueprint read only, and category will be spawn info, and this will be a float probability. I will copy paste this because why write every time the same thing. This I will give a int32 of min quantity, int32 of max quantity. Another thing is f gameplay tag face tag, and I need to include the gameplay tag container.h, and also very important before you compile, we need to in the build.cs I will need to give gameplay tags. Okay, the face tag. Another thing of what else? F vector scale, F rotate, F rotator, rotator, and this will be rotation. Another thing will be a tsoft object pointer of u sound base, and this will be on drop sound, and I believe this is everything. I think maybe I don't know if I forget something. I will see. One more thing that I forgot is to give a meta tag asset bundles equals loot sound, for example. And I'm doing it this way because I read somewhere in Epic's documentation that when you async load the primary asset list and you give the bundle, um, those two, the variables that have a meta tag of asset bundles will be loaded in memory as well. So now I can really resolve the soft reference and store it in a runtime array. So I will build. So everything was all right. Uh, I closed the rider because I don't need it anymore. The only thing I want to change is from the spawning for runtime, the sound base can be now object reference instead of soft object reference. I can close this and create data asset of this type now, PDA spawner, and say DA spawn level 1. And I will go to the project settings, to the asset manager, and I will give one more element to scan. So now I will do a primary asset type of, actually I will do first the object and say PDA spawner. And for some reason Unreal doesn't recognize if we don't put the C in the end. Has blueprint classes should be false, and directory will be the path that the PDA spawner leaves. So the PDA spawner get the path and give the directory to scan the location. Okay. Another thing that I want to make before I go to the component is I want to make another primary data asset, primary data, but this time will be a generic primary data asset, and this will hold the two structs of the rarity and element. So PDA element and rarity info. Open this and I will give element information and rarity information. And the first one will be as spawn as element information, and this will be an array. And the second one will be as rarity information, and this will be also be an array. Now I can make a data asset from miscellaneous of type PDA element and rarity info and call it DA element and rarity. And because I don't want to bore you with populating those two arrays, I will see you in a bit. Okay, so I gave 4 element tags and 7 rarity tags. The element tags is fire, air, earth, water. I gave for each element to have 25% chance to drop um, with the specific element, and I gave poor, common, uncommon. I didn't make any materials because for this video the purpose is to just spawn and maybe print the tags. Either way, the tags will be useful if you have a component of type weapon manager that you actually can use and say, for example, if your weapon has some sort of durability, if the rarity tag is poor, maybe the amount of durability is very low. But if it's godlike, maybe it doesn't even break. This is just an example, but this kind of logic will you will do in the manager component in when you equip the weapon, because the spawner doesn't really know doesn't really needs to know this kind of information. And I think the blueprint class you could put theoretically to the blueprint class, but I use the item base and the weapon base as visuals only. So yeah, now I can close this. I have just the elements and the reality. I don't have any materials because I don't think I will put any visuals in this project. But anyway, and now I can open the component. In this component, I had the primary data asset that was holding an array of structs, and the struct had some information like class ID, probability, and I was adding. Um, I think load primary asset class list, and then spawning. Nothing too crazy. Now, what I want to do is to delete everything because I don't need it anymore. And uh, before I delete, I can show you the class ID of type primary asset ID. This was this is asset ID of type actor, and now I have asset ID of type primary data asset. So I can delete everything, compile and save, and I can delete the loaded object class reference, or actually the loaded objects, and the spawn info. We can keep the class ID, and I will give the runtime array info, and this will be a struct of s spawn runtime, and will be an array. And this will be private as well because the owner doesn't need to know what this array has. And I can say custom event find data. So now I can populate this array and say, okay, I want to spawn this data set, and I want also to spawn this one. And I can do async load primary asset list. And if we read the Unreal documentation, it says load the list of primary asset objects into memory until I say to unload. And it also says if load bundles is specified, those bundles are loaded along with the assets. So now that in my primary data asset I have um, the meta tag asset bundles of type loot, I can say make array give loot, and I have another one is loot sound loot. uh, I don't remember, I will check later. So in completed I can say for each loop and cast to PDA spawner. And from the PDA spawner, I have all the information: get actor class, get sound, uh, get probability, and I think now that those two belongs to these bundles, they are already in memory, so I can safely do a sync load class asset inside the loop. Or I could also say resolve soft reference and um, and if this probability is greater than a random range and random floating range, if this is true, I can add to the runtime array, make, and now I can connect and have the information um, inside the runtime array. I can do the same resolve soft reference and add to the struct info. And the nice thing about this is that I can say in completed, I can say unload primary asset list, and the primary asset list will be this. And I'm doing it this way because I don't really need um, to be in memory the class asset IDs anymore, because I will have my runtime array. So I could say, for example, custom event, spawn assets, and the assets that I'm going to spawn is from the runtime array. And I will do a for each loop, break, and spawn actor from class. So I don't need the uh, primary asset list to be uh, loaded in memory, and some class even won't be past the condition. So it's kinda dumb to live in memory. So yeah, and before I spawn the assets, I will get all the necessary information, get scale, get rotation, get mean quantity, and get max quantity, get phase tag, and get spawn info type. And now I can add to the runtime array, and I will have all the necessary information. So now I want to do the spawn actor inside here. I will give an input of phase tag, phase um, spawn phase, and this will be a gameplay tag. And if this tag matches with this tag, I can say in spawn type switch, it is true switch, and now I can make functions for each type. For example, what I want to do is spawn items and spawn enemies. And the great thing about this is in the class ID, because I load the primary data asset or a data asset, I can give uh, anything for the actor class. So I can give enemies, I can give effects, I can give items, but if I do a primary asset ID of type actor, I need to have an asset ID for items, an asset ID for enemies, an asset ID to effects, and yeah, have all these different directories that the asset manager need to scan. But I can now with the data asset, I can have everything inside the primary data asset. So spawn items in item and spawn item enemies in enemy. And for the spawn items, what I need is the class of type actor, class reference, not object. Another thing is the quantity of type integer. Another thing is scale of type vector, rotation, and this I believe this is it. And you can I won't use the sound now because I don't have any sounds, but you can pass the sound from here and have some interfaces to send the data to the item base. So the class goes there, the quantity oops, goes there, and the scale goes there, and the rotation goes there. And same thing with the enemies. So I want to have a class of type actor, class reference. The quantity I will use is how many times. And scale of type vector. I don't think um, I don't think I need the rotation for the enemy. So the scale goes there. The total quantity goes there. And the actor class goes there. So now I am in the enemy. I can do subtract 1 for loop, and this will be the last index. I will say get owner, get actor location, and by the way, this should be an interface and have a random location that you want to spawn um, in some sort of range, but for this it's okay. And I will say spawn actor from class, split this, collision is try to adjust location but always spawn, and the location is here, the class is get class, and this class is from this input, and the scale is get scale. So if I have a data asset that holds an enemy and say, okay, I want to spawn um, a mini spider or a mini skeleton and give a quantity, it's simply spawn this class this many times. So if I have 10 times, spawn the mini spider 10 times. Okay, and for the spawn items, it's the same. So I will say spawn actor from class, get owner, get actor location, split this, get class, get rotation, and get scale. Okay, so now I think I can test this. And do I have level 1? Okay, the spawn time type will be an item. What I want to spawn is a sword, maybe wooden Viking sword. Probability will be 100%. Quantity 1, 1. Face tag, I will say on death. The scale 1, 1, 1. Rotation be like 50. And the sound I don't use, but this is when the actor is getting spawned, you can put whatever you want. And for the spawn level 2, I will clear this. And what I want is VP enemy. Actually, I will make a child. VP enemy, yeah, child. And the probability will be 1. The mean quantity can be 3 and 3. And the phase can stay um, spawn.phase.1. And the spawn time, don't forget to put enemy instead of item. So I can delete this now and go to the enemy. And inside here, I just hardcode the part. I can say now, oh, this I had to be private, but now I will use from the enemy. So I can say now in the enemy, the class ID, I want to spawn the level 1 and I want to spawn the level 2. So here in health change, I can say, I can take the spawn system and say find data and then connect to health. And if I put a breakpoint here and play and press to lose to reduce health from the enemy, now the class ID has two elements. I async load the primary asset list with these bundles. And yeah, so now the primary data assets and the soft class reference with the asset bundle of loot is already in memory. And the probability should pass either way because it's 100. I can and on completed I unload the primary asset IDs. And this I think because this is in memory now, I think it's okay to do this. And and this is a very nice thing to have, because what if the probability doesn't pass the condition? Now you will have many primary assets inside the memory. Uh, the assets will be loaded in memory, but you won't even use them. So the array is 2. I won't spawn anything because I haven't told the system to spawn, but and I can remove this. But if I do, for example, in health to be lower than 60, if I take the spawn system and say spawn asset with the spawn phase 1 and say on death spawn asset with spawn phase on death and play, health is 90, 80, 70, 60. So the system spawned, it's like mini spiders or mini skeletons. Like this is looking very bad, but if you had visuals, enemies, etc., this will look cool. And 50, 40, 30, 20, and now the sword is uh, got spawned, and the enemy base died. And yeah, by the way, you should never do this in enemy. I mean to populate the class IDs from the enemy, but every type of child should have their own unique class ID list. And yeah, so I won't do anything else for this video, just to know that you can do this. And probably you should have a function custom event to say clear array, and this is very important to clear the array. So anytime the enemy dies, you should call this. Or if I don't know, you hit the enemy and after 10 seconds the combat state finished, you should clear the array. So you won't have any hard reference all the time. And one other thing that I want to make here is to give the element and rarity info, and this will be PDA element and rarity info object reference, and this will be single. So now I can do, for example, set get element tag, and this one will have three local variables of type float. This is total probability local. This is probability ranges local type float, and this is a roll chance. So this function, uh, because I have 4 elements, I could use something like random integer in range and say the min is 0, the max is 3, so each element has 25% to get spawned, and then maybe I could switch on int and say 0 is make a tag and say 0 is element.fire, 1 is element.water, but this isn't very scalable. And if you have theme levels, like suppose you have a mountain with lava, maybe you want to have higher probability to drop the element of fire. Or if you are in an island, maybe you want to have bigger probability to spawn water. That's why I am doing like this. And for this function, I set the total probability to 0, and then I get get element information, do a for each loop, break, and I get the total probability, and then I am setting it again, and I'm adding. And this it's unnecessary, but it's nice to have some safety because I could make a mistake and the probability wouldn't be added. Uh, the total probability wouldn't be 1 and it could be 1.20 or 2 or whatever if I made the mistake. So now I can say on completed, I can get this for later and say on completed the probability range is 0 and the roll chance is a random floating range and the mean is 0 and the max is the total probability, this probability. So now even if I made the mistake, I can include all the ranges and I will do for each loop with break, break, and I will add the probability to the probability ranges and then I set to be this 1 and if the roll chance, this 1 is bigger than uh, actually if this is less, it's the same thing. But if this is less than the roll chance, I will break the loop and I will return the element tag. So the logic here is uh, I set the probability range to 0, then I have a roll chance. Suppose that the roll chance is 50, for example. Um, then you looping each element. So the fire has 25%. Okay, it's not, it's false. Then you add the next probability. So you making ranges and you on completion you return the element tag of the uh, array, the struct array. And for reality will be the exact same function with the element tag. So I can duplicate this and say get reality tag and instead of element information I can say get reality information and I will loop over this, break, the probability goes there, we can hide the unconnected pins, get reality, loop over this, break, and the probability goes there. And if this is true, I will return reality tag and the material source object or material interface, and this will be soft object reference. So this goes there, this goes there. And this I can use then in spawn items and say before I actually spawn the actor, I could calculate the reality and the element tag and then have an interface which I call from the spawn actor and pass around the data to have the information inside the blueprint. I think this is all, and you could make anything you like. So if I go again to the spawn info and say spawn an item, now spawn a ball, the probability is 1 and spawn in phase 1, this I don't need, and from the enemy I can say spawn level 3, then I can play, reduce the health and spawn the ball and the enemies. So baby child 0, 1, 3. Okay, okay, before I end the video, I did some things that I have done in some previous in the previous one, and what I did was I changed the name. So now I know which data set I want to spawn. For example, the giant enemies is an enemy child and has a big scale. Uh, and the For example, the wooden sword is of type wooden sword blueprint. I spawned this on death. The scale is 1. And for testing, I gave the probability to be 100%. Also, in the spawn system, I made a function that delays for 5 seconds or maybe 10, and then unload the class ID, the primary asset ID, and I add to the struct. From the struct, I loop over and I spawn enemies and items. And I have another one function that clears the runtime array. Also, I made two interfaces that I use in the um, item base. I use to send data from the spawner to item base without hard referencing. And the interface for the item base, I have a function with a boolean input, a gameplay tag, gameplay tag and material object soft object reference, and quantity of type integer. And I also made a material, and this is masked unlimited two-sided. It's a very simple material that I use to set the overlay. In the third person, I use the keys just to test things, and I made a BB spawner that has the component and the box collision that I set in the world to spawn um, for example, many enemies. So if I press 3 on my keyboard, it finds the data with the asset ID, delays 5 seconds, and spawn the enemy. And in the item base, I um, implement the interface. I do nothing with it for now, but the only thing I do is set the material overlay. I cast, and if it's static mesh, then I set the overlay material to with a target of static mesh, and if it's not, then it's a skeletal mesh. Then in event set drop, I add impulse of 1000 in the z-axis. And in the enemy, I just play a montage. I drop on death, then I clear the array and destroy the actor. And I gave the phases. This is phase 1, phase 2, phase 3. And then if health is 0, I call on death. And I gave another interface that basically I get the world location of this collision box, which is 400 by 400, and I gave back to the BBC spawn system. So this is the random location, which is I get the owner, get the box collision location, random point in bounding box, and return the location. And the interface is I just have two outputs, world location and half center. So now if I play, in my level I have the enemy base and the spawner test, and um, it's in the air to see actually the results. And if I play, I will press 2, the enemy health goes to 90, spawns the giant enemy in phase 1, spawns a random number of mini enemies in phase 2, in phase 3 I don't have anything, and on death, when he dies, it spawns the loot with the rarity. So if I play again and spam, now the shield is rare, the wooden sword is also rare, This is common, this is uncommon, and every time it's something different, completely random. And if I press 3 now, I set the timer, the delay, and after 5 seconds I can spawn many enemies. And yeah, this is basically I can um, it needs to have some sort of better calculation about position and location, because some enemies may overlap with others. But for now, just for testing, it's very nice, I think. And it spawns every time. So now this is epic, this is poor, this is uncommon, and this is common. So that's it. Um, Thanks for watching.